So for this, first step we're going to do is we're going to multiply both sides by dx. And it's going to cancel out all of these dx's here. And we're left with derivative of u times v equals u dv plus v du. And then we're going to take the antiderivative of each side. And I'm going to split these up, take the antiderivative of each one separately, since we can do that with addition. On this side, we're doing the antiderivative of the derivative of u times v. So antiderivative of the derivative, those are inverses. We're going to get u times v. And we should have plus c, but we're going to save that for the end. We're just going to put it on one side. For this, over here, we can't really do anything to simplify these. We just have antiderivative u dv plus antiderivative v du. So what I'm actually going to do here is I'm solving for this first integral, u times dv. I'm going to subtract the antiderivative of v du. And that's going to leave us with our formula for integration by parts. Antiderivative of u dv is equal to uv minus antiderivative of v du. And I'm not even going to put the plus c because we still have to evaluate this integral, so that plus c would come from that. But that's our formula for integration by parts. And we can kind of fill that in below here as well. Right, antiderivative of u times dv is equal to uv minus antiderivative of v du. So what helped me remember it as a student was UV, like the sun, UV rays, minus VDU. I thought of voodoo, VDU, voodoo. So that's what helped me remember these. But this is the formula we're going to be using for some problems over the next couple days. And it's a little different than our normal U substitution. A couple notes. dv must include dx. So we're going to set up, like, we need to figure out what u is and what dv is to start off. Well, dv has to include the dx part in it. Let dv be the most complicated part of the integral that can be integrated nicely. And what do I mean by nicely? We'll look at this with some problems later on, but we want to try and get something that maybe looks a little complicated, but we can do the antiderivative, and the antiderivative does not look too complicated. One thing you want to kind of keep an eye on is when we look at the complicated part of the integral, look at that part and kind of decipher to yourself what is nicer, what is simpler, the derivative of that or the antiderivative. And we'll talk about that more with some examples as to, like, what do I mean by nicer, what looks better.